Okay, so today I will focus on how to solve first order nonlinear PDE. Okay, so earlier, whatever you know, that is how to solve a quasi-linear partial differential equation, that is by Lagrange's method. Okay, so that is the form is PP plus QQ equal to R. Clear? Okay, so this time this is more general. This may be nonlinear differential equation, and it is of course first order. Yeah. So how to do that? And the method we will be using, that is known as the Charpit's method. Okay, so how it works? So let us try to understand it. First, we'll start with the general form of the first order equation, which may be nonlinear. Clear? So that means maybe their Z into P and Q may occur, P into Q may occur, power of P more than 1 or anything apart from 1, it may be there. Clear? Okay, so our target is to find the complete integral, or means general solution of the first order nonlinear partial differential equation. Okay, so this is the form we can write, because okay, you can see it. You can see the screen, PDF file, response me.
Yes, sir. Yes, sir.
Okay,
Yes,
so
sir, visible, sir.
Yes, it's visible.
okay, I annote on the PDF that is also visible.
Sir.
Yeah.
Yes.
Okay. So as usual, here the independent variables are X and Y. Two independent variables, and dependent variable is only one, that is Z. So this is most general form, and P is ZX and Q is ZY. That is the standard notation for small p and small q. So P is ZX and Q is ZY. Okay. And now, whatever your f, the domain of definition of f is a D, and this is basically f from D to R. Okay, and basically this D is a subset of how many components are there? Are 5. There are 5 components: X, Y, Z, P, and Q. And f has to belongs to C2D. F has to belongs to C2D. What's the meaning of C2D? Second time differentiable. It is continuously differentiable. Okay, C1 functions means continuously differentiable. Cn means nth time differentiation exists and continuous. That nth differentiation is also continuous. Okay, so that is what the meaning of C2D. Clear? The basic idea of this method is to introduce another partial differential equation in such a way that f and this equation are compatible. Compatible means what? We like to have a common solution. Okay, so a given equation is 1.1, this one. This is your given equation. We like to find another partial differential equation of the form G X, Y, Z, P, Q, A. Here another thing, one arbitrary constant A is there. So this is your 1.2. This is another differential equation, partial differential equation we like to find in such a way that they are having a common solution. Clear? Okay. Okay, so from 1 and 2, we like to find two relation of the form P is equal to P of x, y, z, A, and Q is equal to Q of x, y, z, A from the above two equations. Means 1.1 means given equation 1.1 and 1.2. Clear? So how to do that? We have to differentiate 1.1 and 1.2 with respect to x and y to get px and qy. You see, this is your px, qy, qy. So ultimately, we have to eliminate px and qy to get this thing. Clear? Okay. So this is very simple. How to initially we differentiate partially with respect to x and with respect to y. We will get two equations. From the two equations, we have to eliminate px and qy to obtain this thing. Clear?
Sir, what are the functions we eliminate?
Px and qy.
Okay.
Px and qy. Because p is involving, so if you differentiate partially with respect to x and y, then we'll get px and qy. Clear?
Okay.
So we have to eliminate px and qy to get this equation, and we solve 1.2 that equation to determine g from the following auxiliary equation. So we have to find a partial differential equation g which is compatible to your f. Clear? As I told earlier, we have to find a partial differential equation g x y z p q and a. Clear? Here additional thing is a. This is going to be 0, and this has to be compatible with f. Compatible means what? Meaning is that they are having a common solution. So we have to recall this thing. This is known as the auxiliary equation and Charpit's auxiliary equation. This we have to recall. And these equations are like dx by f of p. Fp means what? F is your number one equation. That is what? Can you recall? F is x, y, z, p and q is equal to 0. So okay, dx by f of p, dy by fq, dz by pp, sorry, pfp plus qfq, and dp by minus fx plus pfz, and is equal to dq by minus of fy plus qfz. So this is your set of Charpit's auxiliary equations. So what is our target? Our target is to find a solution, find basically G. This is our target, to find a partial differential equation G. Okay, so depending on the differential equation, we like to form a relation, actually two relations. P is equal to P of x, comma y, comma z, comma a. There will be no other terms here. And q is equal to qxyza. A is some integrating constant. This is so. From these set of equations, we have to find these two relations. After that, what we do? After that, we use this thing. This is basically from chain rule. dz is equal to p dx plus q dy. And this is integrable from the condition, given condition. So dz is equal to p means whatever we find p x comma y comma z comma a dx plus q x comma y comma z comma a dy. So from this equation, this is again we have to use certain tricks to find to integrate it in order to get a relation of the form phi of here. If you integrate, then definitely one more integrating constant will appear. Say for example, that is b. B is another integrating constant. So ultimately, whatever the relation we will get, that is a relation between x, y, z, and a will be there. A is arbitrary constant here. A and another arbitrary constant or integrating constant will come, that is b. So this is your complete solution of the given equation 1. So we are done. Okay. So I think it seems to you that it is very difficult, but once we solve some questions, then you will you will learn how to do that. Okay. So starting example is like that. This is solved example from your lecture from the lecture note. What is that? 2z plus p square plus q into y plus twice y square is equal to 0. So this is say for example, this is your given partial differential equation. Okay. Now whatever the known method so far you know, only one method you know, that is Lagrange's method, pp plus qq equal to r. This is a quasi-linear differential equation where capital P, Q, and R, these are functions of x, y, z. Clear? But here you see that P square is there, so definitely it is not linear or non quasi-linear. It is a non-linear partial differential equation. Straight away, y square is there. Sorry. Okay, so first what we have to do, we have to write the equation in this form. F is equal to a function of x, y, z, p, q. So it is already written because it is in the left hand side, right hand side is 0. So we write it this. This is your starting equation. Okay. And then straight away we like to find the Charpit's auxiliary equations. Can you recall, Prajata? Dx by fp is equal to dy by fq is equal to dz by pfp plus qfq
Equal to
is
dp
equal
by
to,
minus 5
yes,
fx.
dp by, how to recall it? Dp by minus of fx plus x and z will be there. Minus of fx plus p fz, and dq will be minus of fy plus q fz, y and z for q, and this q will be there. Okay, so in this way you can recall it.
Yes, sir.
So then we have to do that. What is your fp? What is your fp?
Sir, fp is only 2p.
Yes, fp is 2p, only 2p. What is your fp? This is your 2p only. What is your fq? You can find from here. What is
Just
your
2.
fq?
1, 1. Fq is 1.
No,
Say
Y, sir,
y, sir. Sorry.
y. Okay. Similarly, you can find your fz. These things you can find. Okay. Okay, so ultimately it is coming dx by twice p is equal to dy by y is equal to dz by p into fp plus q into fq. Like, this is simple calculation, all of you know that this thing. Okay. Now what are the equations we will take first? First and fourth. First and fourth. If I take these two, then what we will get? Dx by p is equal to dp by minus P, okay, P will be cut it out. Ultimately, dx is plus dp is equal to, because it is minus. So dx plus dp will be 0. That means what? X plus P is equal to A. Okay. So understand this thing?
Yes.
We have to take suitable. Somehow we have to find two relations. What are the two relations? Pj is function of x, y, z and a, and q is another function of q of x, y, z and a. Okay. So these two things we have to find initially. Then we have to apply dz is equal to p dx plus q dy. Okay, from this we have to integrate in order to find a relation between x, y, z and a and b, another integrating constant b. So that is our ultimate goal. Okay, so ultimately, so p is equal to, that means what? I can write p is equal to a minus x. So ultimately, p is a function of x and some arbitrary constant. Actually, general thing is what? General thing, it is a function of x, y, z and a, but may not be always we get y, z like that. Okay, so we will get one relation already. Next, what we will do? Okay, we like to use this equation p is equal to a minus x, and this 1.9, this equation in the equation 1.7. What is 1.7? This is in the given equation. Okay, so what we get? We get twice z plus a minus x whole square, because it is p square. Earlier it was p square. Plus qy plus twice y square equal to 0. Okay. That means ultimately what we get, q is a functions of x, z and y. So we'll get two things, that is p is equal to a minus x, possibly a minus x, and q is equal to this. Q is equal to this. These two are two things we get. So next we have to use dz is equal to p dx plus q dy. That is the that is from chain rule. We can write dz is equal to p dx plus q dy, and it is integrable, So you can integrate it to find your complete solution. Yeah. Dz is equal to what is your p? That is a minus x dx. What is your q? Q is equal to this one. So we put it here. So in order, if we put and do the calculation, you understand that here there is a catch. We have to somehow separate in such a way that we can integrate it. That is our intention in order to integrate the given equation. So how it can be integrated? If you see that we have to multiply both sides 2, whatever in the denominator, twice z plus x minus a its whole square plus y square. In the numerator, if we look at,
Sir, one question, sir. Sir, how is minus z by y coming separate in the Q, sir? Where is the minus z by y coming from?
okay, let's check.
Because Q is minus 2z, like just the fractional portion, sir.
P is a minus x, that is your P. This part is clear. Q is equal to this one. Okay, no. This part, I think it is mistakenly done. This is not. Okay, so you are correct. This will be there. Then you do that. Ultimately we can write 2 into d of something divided by this denominator plus 2 by y into dy equal to 0. So if we integrate it, we get ln twice z plus x minus a whole square plus y square plus 2 into ln y is equal to ln b. Say for example ln b, because in order to make it easier. So ultimately what we get, y square, this will be coming in here, y square into 2z plus x minus a whole square plus y square is equal to b. Right hand side ln b. So this is a relation between x, y, z and a and b. A and b are arbitrary constant. So this is the complete solution, a complete integral of the given equation. So I think you understand it. Once you get this note, then if you do it in your notebook, then it will be more clear. Okay, so I think you understand first whatever the given partial differential equation, that you have to write in as f x comma y comma z comma p comma q equal to 0. That means you have to make it in the left hand side. So say just we see the second one, then you understand it. Second example, find the complete integral of the equation p square plus q square y is equal to qz. So this is your second exercise today. The given equation we have to write in this way. P, that means p square plus q square y minus qz is equal to 0. So you have to make it in the left hand side to write in the form f is equal to 0. So then Charpit's auxiliary equations are what? Dx by fp. I write it here. So we have to do the calculation and then we can write in this way. Clear? So this part is absolutely easy, because you have to recall the Charpit's auxiliary equation, how it can be done like that. And then you will get it, because you can calculate what is fp, what is fq, and what is fz, etc., fy, etc. Okay, fx, like that. So next we have to choose ratios in order to find p is equal to p of x, y, z, p. No, and this is a, and q is equal to q of x, y, z. A is some arbitrary constant or integrating constant. We have to find these two relations initially. Okay. So fourth and fifth we have to take. these two. We'll consider these two, fourth and fifth. So dp by pq is equal to dq by minus p square. So ultimately it is pdp plus q dq is equal to 0. That is what? P square plus q square equal to a square. Okay. Once p square plus q square equal to a square, so we can put this thing in the given equation in order to get another relation. Okay. So if we write p square plus q square equal to a square in 1.13, let's see what is 1.13. This is in the given equation. So p square plus q square is there, so that is why we try to use it. Then ultimately it is a square into y minus qz is equal to 0. So q I can find in terms of y and z and maybe a. So q is equal to a square y by z. So this is your second relation. We get it. And what is our first? First one is p square plus q square equal to a square. This is plus. That means p is equal to this one. Okay. But we like to find, we don't like to find p is a function of x, y, z, p, q. That is not. What is p is a function of?
Sir, X, Y, Z, A.
Yeah, very good. So there will be no q, no p. Okay, so this q we have to substitute because already we get q is equal to a square y by z. So we get it this. Ultimately, this is a by z square root of z square minus a square y square. Okay, so we get p in terms of x, y, z, and a. Okay, and similarly we get p. So what we are getting, we get it. P is equal to a by z square root of z square minus a square y square, and q is equal to what we get a square y by z. Okay. A square y by z. Okay, these two things we get. So these are the second step. First step, okay, maybe it is third step. I write what is, okay, I will be coming later on. So then we have to take this dz is equal to p dx plus q dy. We have to put what is your p and what is your q here. Then we get it. And then we have to integrate it. Somehow we have to integrate it. And this integration again, you see, these are basically not in a very separate way. If it is separated, then you are lucky. You can do it very easily. If it is not separated, then you have to use your brain how to do the integration. That's all. So ultimately, this thing is there. Then
Sir,
this is your solution. Yes.
Sir,
Okay.
solution we get. Sir, solution we get by this method means Charpit's method will be unique or not?
The complete integral is unique.
Okay, sir.
Okay, so form little bit may be different, but it is my system will be unique. Your because it involves two arbitrary constants or integrating constant. It may not looks like exactly same. Sometimes you can say, for example, ln x, ln a. You can make it another constant c, no problem, because these are arbitrary constant. Sometimes some arbitrary constant comes like 2 c by 5. You can make it another arbitrary constant d. D is equal to 2c by 5. Clear?
Sir, could you go up to the pdx plus qdy equation once? I just want to check one thing, sir.
Yes.
Yes, sir. Thank you, sir.
Okay. Okay, so you understand this thing. Okay. Now I am having some time more now. Yes. And should I solve another question in OneNote?
Sir, we have an exam tomorrow morning.
Yes.
Okay, just like to revise it. What are the things we have to do it? Okay, so I come back to OneNote. Okay. Suppose something like px. You can see q is qy equal to
Yes, sir.
pq. Okay. So whatever your partial differential equation is given, first step is one. First step is what? We have to write f in this way. F we have to write px plus qy minus pq. Means in the left hand side. And f is a function of, who can recall? X, Y,
Sir,
Z,
X,
P,
Y,
Q.
Y, Z, P, Q.
Very good. Second, what we have to do, I just like to revise the steps, whether you can recall it. Second, we have to write the Charpit's auxiliary
Auxiliary.
equations. Clear? Okay. So we have to recall Charpit's auxiliary equations. And then after writing Charpit's auxiliary equations, let us write it dx. Any one of you try to say dx by fp is
So
equal
dx
to
by fp,
dy by
dy
by
by
fq,
FQ.
dz by pfp plus qfq equal to dp. Sorry. Equal to dp by minus
minus of, yes,
fx minus of
fz plus
fx.
pf fx plus pfz
pfz
Yes, very good.
equal to
equal to
dq minus of
dq by
fy plus qfz.
yeah
Minus of fy
Fy
plus q. This
qfz.
q and this q are same. Q f z.
Yes, sir.
Okay. Okay. So this is your step number 2. Okay.
So after
Next,
this, check any two equalities and solve them to get P.
we have to suitably take any two and then again any two to find a relation. P is a function of P of x, y, z, and one arbitrary constant a. Another we have to find from this, or maybe we can use in the given equation also. We can use in this, like in the second exercise, we have used whatever we get in step number 2, means using Charpit's equation. Whatever we get, we can use it in step 1 to get another relation. Okay.
Yes, sir.
P is a function of x, y, z, and a. Okay. Once we get this is your step 3. What is step 4?
So place it
We
in
have
an
to
equation
use
dx plus qy
yes,
equal to
c dx plus q dy. From this we have to put this p and this q here. Sorry, this p and this q here, and then we have to integrate. So finally, step number 5. To get our aim is to find a relation phi x, y, z, and
A and B, sir.
yes, sir.
a and b. So definitely this is going to be equal to 0. These are arbitrary constant or integrating constant. This is arbitrary function. Clear? And now see, whatever your first order, that is why number of arbitrary function is equal to 1 in the complete integral. If you get phi1 of something plus phi2 of something is going to be equal to 0, and phi1 and phi2 are two arbitrary functions. So this will not be the complete solution. You understand? Because we are focusing a nonlinear partial differential equation that is of first order. Yes, so only one arbitrary function will be there, and this is the form of clear. I think now it is very much clear to everybody. Okay, this much
Yes.
for today. Let me take the attendance. Today number of students is also less.